Good evening YouTube, my name is Yusuf and you're watching my news channel. Today we are May the 26th of the year 2021. As expected, the CME arrived, but not when it was predicted to arrive. So it happened today at 11 UTC, but when we look... Oh, it's not there anymore. No problems. And little spiral, where are you? There it is. Let me just put this here. So when we look at the simulation of the Space Weather Prediction Center, we could see that it would arrive at yesterday at around 16 UTC. No, actually, yes, 18, more or less 18 UTC, that the initial impact. It arrived, however, today at 11 UTC, so this is a little bit wrong. It should be here. But this is, after all, only a prediction based on a simulation, so it is normal to see that sometimes this is wrong. That's why I always say take everything you see from these simulations with a grain of salt. Sometimes it can be wrong. So it happened a bit later, but it happened nonetheless. However, when I look at the solar wind, I see there, after the moment of impact, there is a stable, the solar wind looks stable, until it actually starts to fluctuate and change of direction. And I'm guessing when I look at the simulation, because I see that this CME swept the plasma in front of it, and now we are entering in this portion over here, which is basically solar wind flowing in different directions with different densities. So it is actually unstable, and this can cause the BZ component to go negative and cause fluctuations. This might indeed spark a geomagnetic storm, but if we look at the conditions, for example, the speed only jumped 50 kilometers a second. This is not much. We are around almost 400 kilometers a second, but this is very low in general terms. The density is there, but it is already fading. So I'm guessing that we have actually reached the maximum threshold of that density at 40 protons. Then it is subsiding again. So unless this BZ component goes negative and stays there for a while, I can't see why we would have a geomagnetic storm. Looking at the KP index, I see no reason to believe that it will suddenly go to KP6 unless the BZ component becomes negative, because then energy will flow to the poles, and this way this CME would become more geo-effective. But we will see as time goes by. When I look at the ACE data, I see actually fluctuations which are rather impressive. There is here a dot at 1000 protons, and everything actually jumps. The temperature goes to the maximum. The speed has been upscaled to 1400 kilometers a second for this dot over here. So these are pockets of very dense protons moving at incredible speed and have a very high temperature. And I honestly doubt this is coming from the sun. Maybe this is cosmic rays, maybe the front actually of a cosmic wave that's inbound, which could of course take decades before it hits us, but these are telltale signs that something is happening, and I wanted to show this. So looking at the magnetosphere simulation of the Space Weather Prediction Center, we can't see the initial impact because it starts at 15 UTC and the initial impact is at 11 UTC as shown over here. But nevertheless, we can actually see that you have that initial impact, and then there is solar wind, which is actually more dense more energized and create us more pressure into the bioshock. So, what I want, yes, the magnetosphere standoff distance, of course, crashes into geosynchronous orbit. It almost reaches it. This is completely insane because at current conditions, I can't see why it would go into geosynchronous orbit. And if we look at the model, I mean, the pressure isn't even there to even justify this. This is, of course, I'm not going to rewind this because I want to show something first. Let me just show what I wanted to view with my subscribers. And it is an anomaly. Yet again, let's start with this one over here because here it is best visible. So I noticed, and notice the blue color over here. So there was energy in this inner belt, and then one frame later, there seemed to be data missing. It jumps from 60 minutes to 24, so clearly there's data missing. And after this missing of the data, we find a complete different setup of the magnetosphere. All that blue disappears, and the bioshock came closer. When we look at this model, we can see this, and this happens at around, let me see, yes, it started at 13 UTC today and 60 minutes, and it jumps to 13 UTC 24 minutes, and then all of a sudden that energy that was inside the inner region disappears, the bioshock comes closer, and the pressure diminishes. So evidently something happens. I'm pretty sure it's conductivity, but for some strange reason they cut off almost 15 minutes. As usual, NASA does not want us to see this. You see over here, then a few minutes later after the data blackout up, you have this. So again, yet again, evidence of something going on, and NASA hiding the data, even if it is for only a few minutes, which is very lame if you ask me, from their part. So let's take a look at the CME tracker. Let's start with, I guess we'll go to the next day. There's not data. Yes, of course not. 26th. You know what, let's go to the previous day because, oh yes, I want to show this. So around midnight of yesterday, there was actually a strange CME. Strange in the sense that you could almost see a circle in its halo. And this is rather unusual. But what's really funny is that when I go to the next day, today, when the day started at midnight, it's the exact same timestamp. Let me just pause that a little bit and go to, no, go to the next day, pause, then we go to this next button. There it is. We have the day starts at midnight with a CME, and the previous day it also starts with a massive CME, a halo one. So I don't know if you guys believe in coincidence, but I don't. This is really strange. Okay, by the way, if you haven't already done, don't forget to subscribe to my channel and hit the like button if you actually enjoyed the video. And you can also turn on the notifications. This way you will not miss any of the future content that I make. This is very important, especially if you're going to subscribe. So our final item, of course, the Schumann resonance. So we see that after the impact there is already a signature, and I do expect this to continue. This is important because the Schumann resonance covers the low frequencies of the brain, but also the human body. So this could affect your mood, emotional state, etc., and even physical states to some extent. Before we leave each other, let's take a look at the philosophical quote. I believe it's number 47. The stranger who is kind is a kinsman. An unkind kinsman is a stranger. Yes, this is self-explanatory. So someone who's kind is always a good person. Someone who's not kind will always be like a stranger. This is it, people. Thanks for watching this video. I really hope that you actually liked it, and I guess we see each other in my next video. Take care.